All right, so here we are in section 2, which deals with multiplying and dividing rational expressions, okay? And like I said, the best part about this, you already know how to do this stuff. So this should be a relatively short video, but I do want to start by doing a problem that we would have seen prior to walking into this class. So we want to multiply 10 over 28 times 8 over 15. Okay? Now I know, a lot of us were taught to multiply fractions, you just go left to right. So you would do 10 times 8, which you would get 80, and then you would do 28 times 15. And to be honest with you, I don't even care what that is because I know it's a large number, and I'm not going to do this problem that way anyways. Because the proper way to multiply fractions is to first factor all of your numbers. And then, second, apply the n over n rule, which equals 1. And then third, you finally multiply what I like to call the leftovers. All right? Now, by doing it this way, you are guaranteed that when you get your final answer in step 3, that answer will already be simplified, and that's because steps 1 and 2 is where you do all the simplifying that you need. So let me show you what I'm talking about. I'm going to go back to that tried and true, awesome technique that we call prime factorization. So 10 is 2 times 5. Now 28 is a little bit different. So 28 is going to be 2 times 2 times 7. Now 8 is going to be 2 times 2 times 2. And 15 is going to be 3 times 5. Now, that took me, I don't know, maybe 20, 30 seconds to write down. So the next thing I'm going to do is this. I'm going to write one big numerator in order and one big denominator in order as well. Now, I've done zero math in terms of multiplying things. So step 1, factor is done. Step 2, now I'm going to do the n over n thing. So I see 2 over 2. I just put big ones out front, and then I'm not going to worry about it again. 2 over 2 again. No more 2s, no more 3s, but a 5 and a 5. I can do that. And notice what's left over. And this is what I mean by the leftovers. 2 times 2 in the numerator is 4. And 3 times 7 in my denominator is 21. And I know that is completely simplified, and that's because I simplified wherever I see those little scratching out marks that I did. So I hope you see just how easy multiplying fractions really is. You want to factor first, simplify second, and then just multiply what's ever left over. Okay? So I'm going to do another one just so you can see this process again one more time. So we're going to multiply 6 over 10 times 15 over 12. So here we go, real quick. 6 is 2 times 3. 10 is 2 times 5. 15 is 3 times 5. 12 is 2 times 2 times 3. Okay? Now I write one big numerator in order. 2 times 3 times 3 times 5. And one big denominator in order. 2 times 2 times 2 times 3 times 5. Now, n over n time. I look for numbers in the same, I'm sorry, let me say that again. I look for numbers that are the same in the numerator and denominator. 2 over 2, 3 over 3, 5 over 5. What's ever left over is going to be my reduced answer. I have a 3 in the numerator. And 2 times 2 is 4 in my denominator. So it's 3 over 4. Now, if we can just remember that, then multiplying rational expressions is extremely easy. So let me show you this one. Oops. How about 3 times PQ over Q to the second times 5p to the second q all over 6pq. Now, I know this looks crazy, but we're going to take our time with this, okay? So the first thing, I look at all the numbers. So I just write the multiplication of two fractions. Now I look at the numbers. 3 is prime. Now the p and the q, they do not have exponents, so I'm not worried about it. That q in my the q squared in my denominator, I'm going to write as q times q. Now, the second fraction, the 5 is a prime number, so it stays the same. Now you have p to the second, so I'm going to write 2 p's, and then I'm going to write a q. Now, in my denominator, that's 6. I can rewrite that as 2 times 3, and then pq. So now, I'm going to write one big numerator in order, just like I did in the previous two problems. 3 times 5 times, and then we have 3 p's and 2 q's. Now, my denominator, I have 2 times 3, and then I have 1p, and then 3 q's. Now I'm going to look for things that are the same in the numerator and denominator. So, first thing I see are the 3's. I scratch them out. Now I can definitely reduce 1p, and then I can definitely reduce 2 q's. So here's the first q, and then here's the second q. And then I write what's ever left over. 5p to the second over 2q. And that's your final answer. So if you think about this, all we're doing is we're simplifying the rational expression first, which we did in the previous section, and then we're multiplying the leftovers. And that's it. So now let's get a little bit more intense. So we're going to multiply 2x over x squared minus 7x plus 12 times x squared minus 9 all over 6x to the second. Okay? Now, just like all the way at the beginning of this lecture, step 1, you're going to want to factor everything. Step 2, you want to apply your n over n equals 1 rule. And then step 3, write/multiply the leftovers. Okay? So, please take your time. Directly underneath, I'm going to simplify the first fraction. I'm going to factor. The 2x doesn't factor, it stays the same. The x squared minus 7x plus 12, well, that factors down into x minus 4 and x minus 3. Okay? Now, second fraction. The x squared minus 9. There's that difference of squares thing again. That's going to come up a lot. So x squared minus 9 will factor into x plus 3x minus 3. And then the 6x to the second power. Well, 6 is 2 times 3. And then I have 2 x's. Now, from here, I'm going to write one big numerator in order. 2x times x plus 3 times x minus 3. My denominator, I'm going to do the same thing. I'm going to write one big denominator just in order. So here I have 2 times 3 with 2 x's, and then an x minus 4 and an x minus 3. So in terms of step 1, I'm finally done. It's the hardest step. Okay? Step 2, n over n equals 1. So I'll go from left to right. I see a 2 in the numerator, 2 in the denominator, so they reduce. I see 1x in the numerator and 1x in my denominator, so they're going to reduce. And on the very far end, I see x minus 3 in my numerator and x minus 3 in my denominator, so they reduce. So that is going to leave me with, now, n over n is done, so I'm going to write or multiply what's ever left over. So, in my numerator, it's x plus 3. And in my denominator, it will be 3x times x minus 4. And that's it. Now, some of you may be asking, Mr. Float, how come that x in the numerator and that specific x in my denominator, how come they didn't reduce? And the answer to that is, you got to remember, as soon as you put parentheses around something, think of that as like a bear hug. So this x is contained inside of the parentheses. Therefore, the only way that you can reduce that is if you have x plus 3 in the denominator. And since we do not have x plus 3 in our denominator, you can't reduce that at all. Okay? Now, that honestly is how these problems go. It is literally these 3 steps, okay? The only way that I can make these problems more difficult is by giving you more complicated factoring techniques. That is it, all right? So let's look at this one. So we got 12x minus 6x squared over x squared plus 8x times x squared plus 11x plus 24 all over x squared minus 4. Okay? So I'm going to write my steps on the right-hand side. Factor n over n equals 1. And then I'll just abbreviate this with just the word leftovers. Okay? Now, take a deep breath. Okay, there's my deep breath. Now I look in the numerator of the first fraction. The first thing I see, this is not written in descending order. And I like it in descending order. So if you're looking at this, this is what I'm talking about. So obviously I'm going to highlight so you know exactly where I'm referring to. So that is not in descending order. I wanted to say negative 6x to the second plus 12x. Okay? Now, when I look at that, I sit there and go, oh, well, I have a GCF. So let's go ahead and let's factor out that GCF. So our GCF is going to be negative 6x. And what's going to be left over on the inside will be x minus 2. Okay? Now, let's look at my denominator. Well, my denominator is in descending order. That's great. And that has a GCF as well. However, it is only the letter x. All right. So there's the first fraction completely factored. Now I'm going to put a multiplication symbol. And now we're going to factor the second fraction. So in the second fraction numerator, there's no GCF, 3 terms. So that will factor down into x plus 8 and x plus 3 all over. And there's that difference of squares thing again. So this is going to be x plus 2 and x minus 2. All right. So the factoring, like I said, that was rough, but we're done with it. So now let's write one big numerator and one big denominator. So I get negative 6x times the quantity x minus 2 times the quantity x plus 8 times the quantity x plus 3. All over one big denominator, the letter x, times the quantity x plus 8 times the quantity x plus 2 times the quantity x minus 2. Now, we're going to apply the n over n technique. What I'm going to do is color code everything so you can see what simplifies. So first, those x's will reduce. Second, the x minus 2's will reduce. And then third, the x plus 8's will reduce. So when I go ahead and reduce them, remember, they all turn into a number 1. So this reduces, the x minus 2's will reduce, and then the x plus 8's will reduce. You are going to write what is ever left over. So In the numerator, I have -6 times the quantity x plus 3. And then in my denominator, I have the quantity x plus 2. And that's it. There's your answer. Okay? So, like I said, these problems, they look difficult. All you got to do is just take your time. Okay? Just take your time. Make sure you factor completely. Make sure you write one big fraction. And then use that n over n property. Finally, just write what's ever left over. All right? Now, what we're going to do is we're going to transition into dividing rational expressions. However, like I said, you already know how to do this. So we'll start off with a very easy problem that we would have seen a long time ago. All right? And that is going to be how about 20 over 15 divided by 8 over 6? Well, if you remember how to divide fractions, first, you rewrite the first fraction. Second, division changes to multiplication. And then third, you multiply your fractions. But we know multiplying, we have a technique for that. So that multiplying fractions technique kicks in. So let me show you how this works. Step 1, you rewrite the first fraction. Step 2, division symbol, I'm going to change it to a multiplication symbol. Step 3, 8 over 6 becomes 6 over 8. Oh, that was my step 3 I forgot to write. I'm sorry. Multiply by I forgot the word reciprocal here. All right. Reciprocal is a fancy word for flip. Multiply, remember, we have that technique that kicks in. I forgot to say multiply by the reciprocal. So please, excuse me. But now, our division problem turned into a multiplication problem. So let's go ahead. 20 turns out to be 2 times 2 times 5. 15 is 3 times 5. 6 is 2 times 3. 8 is going to be 2 times 2 times 2. Let's write one very big numerator in order. Then we're going to write one very big denominator in order. Remember, n over n is 1. And you were just going to reduce everything that you got. So this turns out to just be 1. Okay? Now, if you can remember that, you already know how to divide rational expressions. So let me give you one here. We're going to divide 15x to the second over 3x to the second plus 33x divided by 5x minus 5 over x squared plus 9x minus 22. So first and foremost, you are dividing two rational expressions, which means we're dividing fractions. So we rewrite the first problem, or we rewrite the first fraction. Division changes the multiplication. And then we're going to flip or reciprocate the second fraction. So the denominator is now the numerator, and the numerator is now the denominator. So the first step was just to set up the problem properly. Now we have multiplication, so we know factor n over n equals 1, and then we got our leftovers. And that is as hard as this gets. So let's go ahead. We're going to do the first fraction. 3 times 5 times x times x. Now that denominator totally has a GCF. It's going to be a 3x. Now I put the multiplication symbol. The numerator for the second fraction, that's what we're going to do here. So I can go ahead and just write the binomial multiplication of two binomials. And I need two numbers that multiply to give me 22, but combine to give me 9. That is going to be positive 11 minus 2. Now for my denominator, I have a GCF of 5. And from here, I'm just going to write one big numerator in order. And then one big denominator in order. Now I'm going to apply the n over n technique. I'm going to look for numbers that are the same in a top and bottom. 3 over 3, 5 over 5, and x over x. And I also notice that I have x plus 11 in the numerator and x plus 11 in my denominator. So they are going to reduce as well. Now I write what's ever left over. X times x minus 2 all over the quantity, the quantity of x minus 1. And that is my final answer. So if you really take a step back and you think about it, dividing fractions is nothing more than just rewriting it and then you're multiplying, okay? So from here, I'm going to just stop the video. You should be able to do section 2 now. Remember, if you have any questions, all you have to do is ask, all right? I realize these problems can get complicating very quickly, but my thing is make sure you're writing large, make sure you're writing neatly, make sure you're following the technique, okay? And make sure you're using that flow chart. That is there for you to gather your thoughts, okay? So I will see you in the next video, which is going to be adding and subtracting, which if you think about adding and subtracting fractions, you should already have an idea of what to expect in the next video. So I will see you in the next one. Bye.